Hey Stat113 people, so the purpose of this video is just going to be to finish up talking about distribution shape, and so we just have two little minor things to talk about there, but the bulk of the video will be introducing boxplots, which is another really common way to look at the distribution of a single numeric variable. And so, like we've already done dot plots and histograms, this is just a third graph that people often use to look at a single quantitative variable. So before we do that, let's go ahead and finish up with distribution shape. And so our last two little definitions are unimodal versus multimodal. And so a unimodal distribution is going to have a single prominent peak. So these definitions really aren't too tricky. I would say most variables that you look at are unimodal, meaning that, and most of the histograms we've already drawn are also unimodal. So for example, we have this right-skewed histogram that has this one kind of prominent peak. And so unimodal, you could break down the word uni means one, and then mode, or modal is mode, so one mode. On the other hand, multimodal is a variable where there is more than one prominent peak. And so multimodal would be something like this, where you might have one kind of peak and then it would go down, and then you might have another kind of major peak. So in this case, there's going to be two peaks. And so you could kind of think about like examples where this would actually show up. So go ahead and take a second just to pause the video and just think about what's a variable that might have two different prominent peaks. All right, so one example that I think of is height. Height that would be measured on a sample of men and women, because generally there's going to be a peak for males up here and then a peak for females that's a little bit lower. And so oftentimes when you do see this multimodal distribution, it has to do with a third variable, in this case sex, that's not really being measured. Okay, and so let's go ahead and talk about our last graphic for looking at a single numeric variable. So that's going to be a box plot. And so I've given a box plot here of home runs hit that we've been talking about throughout this little note packet. And so let's just go ahead and label what some of these different lines and different points actually mean. And so let's start with the actual box. And so sometimes this is also called a box and whisker plot because you have the box in the middle and then the lines that come out from it are kind of called the whiskers. But we're just going to call it a box plot. And so I'm going to go back to our table of summary stats so we could kind of match up some of these with how they appear on the box plot. And we're going to start with the median, which was 7 home runs. And so where that shows up here, that's the center line in the middle of the box. And so the median, if this kind of white grid line is 10, kind of makes sense that this line would be 7. We could also label Q1 and Q3 the first and third quartiles, which were 3 and 16 home runs. And so Q1 is going to be kind of lower right here, so the lower end of the box, and then Q3 is the upper end of the box. And so those should kind of match up with the summary stats. The trickier part is figuring out where these little asterisks come from. And so these are all classified as outliers. And so if you recall, we did in class, we found some cutoffs for what would be classified as outliers for this baseball home runs data. The lower one was negative 16.5, meaning that there are no lower outliers because you can't have negative home runs at all. The upper bound, or the upper fence point, was 35.5. And so let's label where that 35.5 would go on this box plot. It's not where this whisker ends. It's somewhere in between, like about right there is going to be 35.5. Sometimes that's called the upper fence. Any amount of home runs bigger than that is an outlier, and so that's why they get asterisks. The whisker here ends at the largest number that is not an outlier. Or I should say, to be more clear, the largest observation, we'll say, or case. So that's the only slightly confusing part, is that the whisker doesn't end at the upper fence. It ends at the largest number of home runs that were hit. That's not going to be classified as an outlier. This bottom whisker is the same thing, so this ends at the smallest observation. That is not an outlier in that case, or in this case it ends at 0 because there are no outliers, and so those aren't going to get marked with asterisks. All right, so the last thing you could kind of think about is that we've talked about that this distribution of home runs hit is skewed, which we could kind of see here in our dot plot. We also saw it in the histogram. To see the skewness in the box plot, it's a little bit harder, but I would recommend just turning it on its side so that the smallest number starts on the left and it gets bigger and bigger going across. What you could kind of do to see the skewness is draw a little curve that kind of peaks at the median and then kind of gets smaller and smaller as you go to these other observations over here. If you do that, you could see from the box plot that the distribution is right skewed. And so it's a little bit harder to see with the box plot, so I'd recommend using the histogram or box plot, or the histogram or dot plot when you're looking at shape, but it is possible to also see it from the box plot. Okay, cool. So as always, let me know if you have any questions. In the next video, we will kind of draw a box plot from scratch. So essentially doing the reverse of what we did here, labeling the numbers based on the box plot. In the next video, we'll start with the numbers and then draw the box plot.